Today I am going to discuss about analysis of plane truss. Analysis of plane truss is a basic topic in mechanics of solids. Mechanics of solid is a basic introductory course in civil engineering, that too in structural engineering. Trusses are widely used in the applications of civil engineering such as roof trusses, suspension bridges, and in the industrial buildings. Trusses defined as, first we have to know what is truss. Truss is defined as it is consisting of several members which are interconnected by means of joints. All the structural members are broadly classified into two types. One is called as rigidly jointed structure, another one is called as pin jointed structure. So the truss is the two types. One is called as rigidly jointed structure, another one is called as pin jointed structure. The structure is classified into two types. Among these two types, trusses comes under the pin jointed structure and it carries only a axial force. The moment in the pin joint is always zero. The basic form of a truss is a triangle. The triangle is consisting of three members. These members are interconnected by means of joints. This joint is pin joint. In this pin joint, moment is always equal to zero. And this two joints, we have to provide a supports. And this total truss is subjected to a load, vertical load. Why we have to analyze the truss? That is very important. Why we want to analyze the truss? That is, if you want to design and building any structure, first you have to know what are the forces coming on the structure. That is, what are the forces carried by this member of the truss. To find out that forces, we have to analyze the structure. So the analysis part is very important than the design part. Therefore, to design any structure or if you want to build any structure, first you have to do the analysis of the truss. Therefore, first we have to do the analysis. In this analysis, before going into the analysis part, first you have to know what are all the basic concepts in the analysis. For that, first you have to know what are the types of trusses. For the types of trusses, we have to use the basic equilibrium conditions. There are three basic equilibrium conditions. That three equilibrium conditions are depends upon the type of the structure. The structure, it may be a plane structure or it may be a space structure. The plane structure is having only three equilibrium conditions, that is summation of all the forces in x direction is zero. Summation of force in x direction is zero. That is implies summation of all the horizontal forces equal to zero. Second condition is summation of forces in y direction is zero. This is nothing but summation of all the forces in the vertical direction is zero. Next, summation of moment in the z direction is zero. This is nothing but summation of moment is zero, because in the plane structure you are having only a two axis. One axis is x axis and y axis and another axis is z axis. So along this, it is a two-dimensional structure, means along these two directions forces are zero. Force in x direction is zero, force in y direction is zero, and moment is always rotated in this direction, that moment is zero. Basic equilibrium conditions are these three. These are the static equilibrium conditions. Using these conditions, trusses are classified into two types. One is called statically determinate truss and another one is called statically indeterminate truss. Statically determinate truss is defined as a truss in which the member forces are calculated by using the equilibrium conditions alone, means that truss is called as statically determinate truss. If the member forces are not determined by using the equilibrium conditions alone, means that truss is called statically indeterminate truss. statically determinatress and statically indeterminate. For the statically determinatress, we are using the equation r minus r equal to 0. R means number of reaction components and small r means number of equilibrium equations. We know that there are 3 equilibrium equations. When the number of unknowns are equal to the number of equations available, then that structure is called statically determinate structure. If the number of unknowns exceeds the number of equilibrium equations, that structure is called as a statically indeterminate structure or statically indeterminate truss. Again, in the statically indeterminate truss, it is based on the indeterminacy. It is classified into 2 types. The first one is called as internally indeterminate. Internally indeterminate. Second type is called as externally indeterminate. Internally indeterminate means, suppose if we are taking a truss like this, in this truss it is consisting of, so I am going to explain what do you mean by internally indeterminate and what do you mean by externally indeterminate by using this small example. If in this truss there are 6 members, first you have to count the members. Number of members is 6. That is, this is the first member, this is second member, this is third member, this is fourth member, and this is fifth member, and this one is sixth member. So there are 6 members and 2 supports, and this support is hinged support. It is having a 2 reaction components. One reaction is acting in a vertical direction, that is BA, and another reaction is acting in the horizontal direction, it is HA, and this reaction is BB, and I have applied the joints as A, this is B, and this is C, and this is D. So number of joints is 4 joints. This is not a joint because these 2 members are cross each other. A number of reaction component is only 3. 2 vertical reactions and 1 horizontal reaction. Now I am going to apply the equation to find whether it is statically determinate or statically indeterminate. Again, in the statically indeterminate, whether it is a internally indeterminate or externally indeterminate. To find the statically internally indeterminate, we are using the expression m plus r minus 2j, where m is the number of members and r is the number of equilibrium equations. J is the number of joints. So while taking this particular example, here number of members is how many members? 6 members. So 6 plus available equilibrium equation is R is 3, that I have already explained. Summation of forces in x direction is 0, y direction is 0, moment in z direction is 0. Therefore 6 plus 3 minus 2 into number of joints is only 4, 2 into 4. So the statically internally indeterminacy is equal to 1. Therefore, this given structure is statically internally indeterminate. That is, the members which are more than the number of joints. That is, it does not satisfy the equation. So in this example, if the number of member is here which is greater than this equation, that is 2j minus r, that is, this equation is modified as m equal to 2j minus r, means that is statically internally determinate. Here M, what happens here? M, number of member is 6 and number of joins is 2 into 4, 8 minus 3, how much? This is 6 is greater than 5. Therefore, this structure is classified as internally indeterminate. So, if we want to make this structure as a determinate structure, what we have to do is, instead of 6 members, I am going to remove one member. One diagonal member I am going to remove. So, what happens? Instead of 6 members, this stress is having only 5 members. Therefore, this equation is satisfied as M equal to 2J minus R. So, M equal to 2J minus R means that this stress is a statically determinate stress internally. And next I am going to explain what is the stress which is made up of externally indeterminate. Externally indeterminate, I am going to take the same example. Instead of this roller support, I am going to provide a hinged support, and you know that in the hinged support there are 2 equations. One is vertical reaction, another one is horizontal reaction. Like that, in this hinged support also there is a vertical reaction as well as a horizontal reaction. So, this equation becomes M, that is external indeterminacy is based on the type of the support. External indeterminacy is based on the type of support. Here both the supports are hinged support. So, what happens? Here 2 reactions are acting, here also 2 reactions are acting. So, total number of reactions, this equation is R minus R, where R is the number of reaction components. Number of reaction components, and where small r is the number of equilibrium equations. So, number of reaction components becomes 4, number of equilibrium equations is available is 3. Therefore, the statically external indeterminacy is equal to 1. So, this stress is statically externally indeterminate. So, I have explained 3 concepts. One is statically determinate, another one is statically internally indeterminate, another one is statically externally indeterminate. Statically determinate means the number of reaction components are analyzed by using only the equilibrium equations available. If it is not satisfied using the equilibrium equations available, means we have to go for finding the external indeterminacy and internal indeterminacy. So, after determining this indeterminacy, we have to go for the basic analysis of the structure. In the basic analysis of the truss, there are 3 methods followed. One is called method of joins. Second one is called method of sections. Third one is called method of tension coefficient. I am going to discuss about only the method of joins. In the method of joins, there are 2 steps followed. The first step is determination of reaction components. This is very, very important. Determination of reaction components. Second is determination of member forces. Determination of reaction components, determination of member forces. Again, in the determination of reaction components, we have to use the equilibrium conditions, that is already I have discussed. Summation of forces in x direction is 0, summation of forces in y direction is 0, summation of moment in z direction is 0. We are using that 3 equilibrium equations. We calculate the determination of reaction components. After determining the reaction components, we have to select a joint where only two members are meeting. In that joint, again we have to apply the equilibrium conditions. In that equilibrium of joint, we have to consider only two equilibrium equations, that is sigma h equal to 0 and sigma v equal to 0. We have not considered sigma m equal to 0. Why? Because the truss member is not subjected to any moment. The member forces in the trusses are only subjected to axial force. If you are taking any member in a truss, this member is subjected to only a tensile force. This force is like this. Tensile force means like your pull, it is acting away from the member. So it is denoted like this arrow. This member force is called tension or tensile member force. The another is opposite to this one. We are applying a push, that is the reaction is acting towards the member. This type of force is called compressive force. So the truss member is always subjected to axial force. So we are neglecting the moment equal to 0 in the calculation of determination of member forces. But in the determination of reaction components, you have to consider again three equilibrium conditions. And before going into the analysis, we have to make some assumptions in the analysis. The first assumption is all the members are pin jointed. All the members are pin jointed. That I have already explained. Pin jointed means moment is equal to 0. Okay, the rotation is arrested. It is moved in the horizontal direction as well as in the vertical direction. There is no moment. So all the members are pin jointed. Second assumption is the self weight of the truss is negligible. Self weight of the truss is negligible. Third assumption is the frame should be a perfect frame. Perfect frame means it should satisfy the condition m equal to 2j minus 3. So these three are the assumptions in the method of joints. All the members are pin jointed, self weight of the truss is negligible, and it should satisfy the condition m is equal to 2j minus 3. And another condition is we have to assume the sign convention before the analysis. The sign convention is, I have taken the sign convention, tension forces or tensile forces taken as positive, whereas the compressive force is taken as negative. Compressive force is taken as negative. So this assumption also we have to make in the analysis. And the last assumption is all the loads are to be act on the joints. So the joints only carry the loads. Suppose if you are taking a truss like this, in this truss, before analysis you have to check that all the members are pin jointed. All these members must be pin jointed. That is the first assumption. Second assumption is self weight. We have not considered the self weight of the truss while doing the analysis. Third condition, you have to check this condition, is it a perfect frame or imperfect frame. Perfect truss means it should satisfy this condition m equal to 2j minus 3. Third condition is we have to assume the sign convention for calculating the member force. Tensile force is taken as positive, whereas compressive force is taken as negative. And all the loads, what is the last assumption? All the loads should be acting only on the joints. So the joints only subjected to the loads and the member is not subjected to load. Okay, so the joints only subjected to load. These are the assumptions made in the method of joints. Next we go for the method of joints. In the method of joints, To explain the method of joins problem, I am going to take a simple problem. The truss is made up of a simple triangle. The basic form of a truss is a simple triangle. So to explain that concept, I am going to take a simple truss. This truss is consisting of 3 members, and I am assuming the support conditions. At the point A, the support condition is hinged. At the point B, the support condition is a roller, and it is subjected to a load. This load I am assuming as 50 kilonewton. This load is acting at the joint C, and this member is having a length of 3 meter. And the basic form of triangle what I have taken is an equilateral triangle. Why? Because all the trusses are consisting of several triangles. Several triangles are interconnected. You can see all the trusses, that in the bridges also all the trusses are made up of equilateral triangles like this. That is, it is consisting of several number of triangles like this. This goes on increasing, depends upon the span of the bridge. This is the bridge truss. In this bridge truss, this type of bridge truss is called as Warren truss. So to explain the concept, I am going to take only one triangle in this truss, and this is an equilateral triangle. So this angle is taken as a 60 degree. This angle is also 60 degree. This is also 60 degree. So all the angles are 60 degree. To analyze the truss, first step is you have to calculate the reaction components. To find the reaction components, first you have to identify the reactions. First you see the support A, where the support A is a hinged support. It is having 2 reaction components. One is VA, another one is HA. And see here, this support is a roller support. It is subjected to only a reaction in the vertical direction, that is VB. So first you have to identify the reaction components to determine the reaction components. So you have to determine how many reaction components? 3 reaction components. So the determination of reaction components, we have to calculate 3 reaction components, VA, VB and HA. Now to find this reaction components, we have to apply the equilibrium conditions. The first equilibrium condition is summation of all the forces in x direction, that is in the direction, horizontal direction is 0. And for this condition, I have taken the sign convention. The force which is acting from left to right is taken as positive. The force which is taken from left to right is taken as positive. So adding all the forces in the truss, in which direction? In the horizontal direction. So only one force which is acting in the horizontal direction is HA, and there is no external force. This 50 kilonewton is the external force, whereas there is no horizontal external force. Therefore you have to equate HA equal to 0. That too, this HA is acting in which direction? Same positive direction. So it is taken as plus HA equal to 0. Next you apply the second condition, summation of all the vertical forces equal to 0. Summation of all the vertical forces is 0. For this, I am assuming the sign convention. The forces which are acting in the upward direction is taken as positive. Now I am going to add all the forces in the vertical direction. The vertical direction forces are, these two are the reaction components which is acting vertically, that too in the positive direction. Therefore VA plus VB. Next force is an external force which is acting in which direction? Downward direction. Therefore I have to use the sign convention minus. So VA plus VB minus 50 equal to 0. So we have formed first equation, HA is 0. Second equation, VA plus VB minus 50 equal to 0. This is second equation and this is the first equation. Now you have to apply this third equation. That third equation is formed by applying the moment condition, summation of moment at any point is 0. Here I am going to take the point A. Summation of moment at A is equal to 0. So you have to take the moment at A. And for this moment at A, I am using the sign convention. All the moments in the clockwise direction, the moments which are rotated in the clockwise direction is taken as positive. So this rotation is taken as positive, whereas if the moment rotate in anti-clockwise, it is taken as negative. Now you have to consider this point and you have to take the moment about this point due to the other forces. So due to this force VB, which is acting in upward direction, and I am taking moment about A, so moment is nothing but force into perpendicular distance. This force is a vertical force, so you have to consider the horizontal distance. So moment due to this force is VB into this distance. This distance is 3 meter. VB into 3, and this moment is rotated in which direction? Anti-clockwise. Therefore, I have considered a sign minus VB into 3. Then you have to take moment due to this force. This force is 50 kilonewton, and this force is acting at the center of this truss. Therefore 50 into this distance is 1.5 meter. That is the distance between the horizontal distance between the point C and point A, which is 1.5 meter. This load is acting in the downward. So towards the point A, it rotates in the clockwise direction. Therefore you have to put the positive sign, that is 50 into 1.5, which is equal to 0. Now using this expression, you calculate VB equal to 50 into 1.5 divided by 3. So VB equal to 25 kilonewton. So you arrive the first reaction component, that is VB, which is 25 kilonewton. Now substitute this 25 kilonewton in the equation 2, you will get VA, that is VA plus 25 equal to 50. Therefore VA is equal to 25 kilonewton. So in the analysis of truss, the first part is over. We have calculated all the reaction components. The reaction at horizontal direction at A is 0. The reaction in the vertical direction at A is 25 kilonewton. The reaction at B in the vertical direction is also 25 kilonewton. The first step is over. Next we go for the next step. Next step we have to calculate the member forces. Determination of member forces. The determination of member forces, I have already explained that you have to consider a joint where only two members are meeting. You select a particular joint where only two members are meeting. So I am going to select a joint A. All these joints, that is in this truss, all these joints only two members are meeting. If you are having a truss which is consisting of several spans, you have to select a joint where only two members are meeting. Here all the joints where only two members are meeting, so I am particularly selecting a joint A. So joint A, consider a joint A. At the joint A, first you draw the diagram. This diagram is called as a free body diagram. So we have to represent this member in the terms of forces. This member is AB. So this force is denoted as FAB. Next force is FAC. FAB is the member force along the member AB. FAC is the member force along AC. So consider a joint A where only two members are meeting. That member forces FAB and FAC. And I have considered all the member forces are acting away from the joint. So I have considered the positive sign. At this joint A, there is a reaction component VA. We have already determined this VA is 25 kilonewton. VB is also 25 kilonewton. So you have considered that reaction component also. VA is 25 kilonewton and this angle is 60 degree. So you select a joint where only two members are meeting. Now you apply the equilibrium of joint. In the equilibrium of joint, I have already explained that two conditions of equilibrium are used. One is summation of all the horizontal forces is 0. Second condition is summation of all the vertical forces is 0. To analyze this joint, analyze this member force along the horizontal direction. The horizontal force is acting in this direction is, in this joint is FAB. And for the sign convention, again you have to consider the force which is acting from left to right is taken as positive. So FAB is positive direction. Next you have to analyze, you have to resolve this inclined force towards the horizontal direction. So FAC into the horizontal component is always cos component and the vertical component is always sin component. Therefore, FAC into cos 60 plus FAC into cos 60 equal to 0. So this is the equation number 1, where we are adding all the forces in the horizontal direction. We are resolving all the forces in the horizontal direction. Next, resolve all the forces in the vertical direction. The force which is acting vertical direction is taken as positive if it is in the upward direction. So summation of all vertical forces is equal to 0. So add all the forces in the vertical direction. This force is 25 kilonewton. This is reaction components. It is all acting in the upward direction. Another force is, you have to resolve this FAC in the vertical direction. So plus FAC into sin 60. The vertical component is sin 60, which is equal to 0. Now using this expression, you calculate FAC. FAC is equal to minus 25 divided by sin 60, which is equal to 28.86 kilonewton. Minus 25 by sin 60, so it is minus 28.86 kilonewton. This is the force in the member AC. First you calculate force in AC. Now apply this FAC in this expression FAB. FAB equal to minus of FAC into cos 60. So FAC is minus 28.86 into cos 60. This gives 14.43 kilonewton. Here that force is also minus. So minus of minus. So minus into minus becomes plus. So force in the member AB is 14.43 kilonewton and force in the member AC is 28.86 kilonewton. This member force is positive, whereas this member force is negative. So we calculate only these two member forces by considering the joint A. Next you have to consider the joint B or joint C. So I am going to consider the joint B. At the joint B, again there are two members are meeting. One is AB, another one is BC. Again you have to draw the free body diagram of joint B. At the joint B, first member force is FBC, second member force is FAB. This FAB already you know, and this reaction component is 25 kilonewton. Again this angle is 60 degree, and you have to consider the equilibrium of which joint? Joint B. Already we determined FAB, so you know the FAB value. FAB is equal to minus 28.86 kilonewton. This value already you know. Now we have to calculate which value? FBC. For that I am going to apply any one expression. Summation of forces in the vertical direction is 0. Because I have required only one member force, so I am going to use only one equilibrium equation, that is summation of vertical forces is 0. So the vertical force which is acting here is 25, which is acting in upward, so it is taken as plus, then plus FBC into this forces we resolve in the vertical direction, so sin 60 equal to 0. Therefore, FBC is equal to minus 25 divided by sin 60. So again minus 25 by sin 60 is minus 28.86 kilonewton. So we analyze the truss by finding all the member forces. The member force AB is minus 28.86. Member force in AC is minus 28.86, BC is minus 28.86, member force in AB is 14.43. Among these three forces, two forces are negative and one force is positive, and I have already explained the sign convention for the forces. The positive forces are taken as tensile forces and negative forces are taken as compressive force. Now you represent all these forces in the force table. That is very, very important. So we have to find all the forces, and finally we have to represent all these forces in the force table. The force table is consisting of 4 columns. The first column is serial number, second column is member, third column is magnitude of force, fourth column is nature of the force. Here only 3 members. First member is AB, second member is AC, third member is BC. Magnitude of force means you have to write the values. This magnitude of force, the unit is very important. Here the unit is kilonewton. So AB member force is 14.43. AC member force is minus 28.86. BC member force is minus 28.86. Nature of forces, if it is plus means, here you have to write tensile or tension member, and minus means it is compression or compressive member. Again this member force is also compression. So this force table indicates the member forces and its nature. So in this stress, among the 3 members, 2 members are subjected to compressive force of minus 28.86 kilonewton and 1 member force is 14.43 kilonewton. So after drawing this force table, we have to specify these forces in the force diagram. That force diagram is very, very important. In the force diagram, you have to represents the nature of force and the magnitude of force. So this stress is consisting of 3 members A, B, C, and it is subjected to a load of 50 kilonewton, and this angle is 60 degree, this also 60 degree, and this member is of length 3 meter. First we have to denote the member force AB. AB is nature of force is tensile. Tensile means acting away from the joint. So if you are drawing in the member, it is acting away from the joint. So joint it is acting away, but members it is like this, it is denoted like this. So sorry. So in the member it will be like this. At the joint it is acting away, here also it is acting away. So it is like a pull. So this intensity is 14.43 kilonewton. Next you have to indicate the member force AC. It is compression. In this member it is denoted like this. At the joint it will be like this. Compression means acting towards the member. Member it is acting towards, but in the joint it is acting towards the joint like this, and it is compressive of 28.86 kilonewton, and this member force is also a compressive of 28.86 kilonewton. So this class I have explained all the basic concepts in the analysis of stress by using method of joints and how to denote all the member forces in the truss by using the magnitude of force and the nature of force. Next I am going to analyze a cantilever truss. There is a difference between simply supported truss and cantilever truss analysis. In the cantilever truss analysis, there is no need to find the reaction components. This cantilever truss is consisting of 4 members and 4 joints, and it is subjected to a load of 10 kilonewton, and this length is 3 meter, and this angle is 60 degree, this angle is also 60 degree, this is also 60 degree, and this also 60 degree. So it is a cantilever truss which is subjected to a load of 10 kilonewton. And I have already explained in the simply supported truss, there are two steps followed in the analysis. The first step is calculation of member forces. Calculation of reaction components. Second step is calculation of member forces. But in the analysis of cantilever truss, there is no need to find the reaction components, but we have to start from the free end. Cantilever truss is nothing but one end is fixed and another one is the free end. This fixed support is supported to the wall. This member is supported to the wall. Fixed means it won't move in any direction. It is rigidly fixed to the wall. But the other end, it is free. So I have started from this end. Again, we are using the equilibrium equations. First I have considered the joint B. Again you select a joint where only two members are meeting. Here how many joints are there? A, B, C and D. In this joint, this is not taken as a member, this is a support. So only two members are meeting, that is AC member and AB member. Next you consider the joint B where BC member is meeting as well as AB is also meeting, and consider the joint C. Joint C, there are three members are meeting, CD, CA and CB. So I have to select the joint B. Why I have not select the joint A means this is like a support. So we do not know the reaction at the support. There is no necessary to find the reaction. Therefore I have to start from the joint B. The joint B is the free end. First you draw the free body diagram of joint B. At the joint B, the load is acting as 10 kilonewton and this member force is FBC and this member force is FAB and this angle is 60 degree. So I have considered the joint B where only two members are meeting, FAB and FBC. Now apply the equilibrium equation. Summation of all the forces in the horizontal direction is equal to 0. So summation of forces in the horizontal direction, again you use the sign convention. Left to right is taken as positive. So this force FAB is acting in the opposite direction. So it is taken as minus FAB. Then you resolve this member force again in this horizontal direction. So what is the horizontal component? The horizontal component is cos. So FAB minus FBC cos 60 equal to 0. This is equation 1. This equation is found by resolving all the member forces in the horizontal direction. Next you have to consider the forces in the vertical direction. In the vertical direction, one load which is acting in the downward, that is the external load 10 kilonewton, and the force which is acting in the upward direction is taken as positive. This force is acting in the downward direction, so it is minus 10. Then you resolve this FBC in the vertical direction. Again the vertical component is sine and this reaction is acting in the upward direction. Therefore it is taken as plus FBC into sine 60 equal to 0. So FBC is equal to 10 divided by sine 60, which is equal to 11.5 kilonewton. So FBC is determined as 11.5 kilonewton. Then substitute this FBC in this equation 1, you will get the value of FAB. FAB is equal to minus FAB equal to FBC into cos 60. So FAB equal to minus of this FBC 11.5 into cos 60, which is equal to minus 5.75 kilonewton. So FAB is minus 5.75 kilonewton, FBC is plus 11.5 kilonewton. So we are considering a joint B and we have find the two member forces. One is FAB, another one is FBC. Next you have to determine, so these two member forces are determined. Next you have to determine the member force AC and CD. For that you have to consider the joint C. At the joint C, how many members are meeting? Three members. One is CD, another one is CA, another one is CB. So you select the joint C. Again we have to draw the free body diagram of joint C. At the joint C, this member force is FBC and this member force is FCD and this member force is FAC and this angle is 60 degree. This whole angle is 60 degree. Now resolve all the forces in the horizontal direction. Summation of all the forces in the horizontal direction is equal to 0. So add all the forces in the horizontal direction. Here the first force FCD, which is horizontal direction, this is in the opposite direction. That is, sign convention is this force is, that is the force which is acting from left to right is taken as positive. This is acting in the opposite direction. So minus FCD. Then this force FBC, it is the positive direction of horizontal component. So plus FBC into this horizontal component is cos 60. Then you resolve this FAC, this is also inclined member. You resolve this forces in the horizontal direction. It is also negative, minus FAC into cos 60 equal to 0. Next, resolve all the member forces in the vertical direction. In the vertical direction, you are having only two member forces. You are resolving this FAC in the vertical direction. You will get FAC sin 60, and resolving this FBC again in the vertical direction, it is FBC into sin 60. These two member forces are acting in the downward direction, and we have considered the sign convention. The forces which are acting in the upward is taken as positive. Therefore, FAC sin 60 minus FBC sin 60 equal to 0. These two forces are acting downwards. Therefore, we are using the negative sign. Now, FAC minus FAC sin 60 equal to FBC sin 60. You cancel this sin 60, sin 60. So already we calculated FBC, which is equal to 11.5 kilonewton. So from this expression, FAC is equal to minus of FBC, which is equal to minus 11.5 kilonewton. So already we determined this member force FAB, which is 5.75 kilonewton, and this member force BC, which is 11.5 kilonewton. Then we calculate this member force AC. So these three are determined. Next, you have to determine the only member force CD. For that, we are using this expression, that is summation of all the forces in the horizontal direction is 0. Now apply minus FCD equal to minus FBC cos 60 plus FAC cos 60. So you are getting minus FCD equal to, you are substituting FBC is minus 11.5 into cos 60 plus FAC is minus 11.5. So again minus 11.5 into cos 60. So finally you are getting FCD equal to plus 11.5 kilonewton. Adding these two, you will get 11.5 kilonewton. So all the four member forces are determined without determining the reaction components. That is the difference between the analysis of simply supported truss and the cantilever truss. In the cantilever truss, first we have to determine the reaction components. Here there is no need to find the reaction components. We directly start from the free end. So after determining all these member forces, again you have to draw the force table. That is very, very important. In the force table, you have to mark all the magnitude of forces and the nature of forces. In the force table, first you have to write the member name. Second, you have to write the magnitude of force. This is in kilonewton. Next, you have to write nature of force. The nature of force, it may be a tensile force or it may be a compressive force. The first member is AB, serial number 1. The first member is AB. Second member is BC. Third member is AC. Fourth member is CD. The member AB is magnitude of force is 5.75 kilonewton. So the member force AB is minus 5.75 kilonewton, BC is minus 5.75 kilonewton, BC is minus 11.5 kilonewton, AC is 11.5 kilonewton plus, and CD is 11.5 kilonewton. The nature of forces, here it is minus, therefore it is taken as compressive or compression, and this force is also compressive BC, and this is taken as tension, and the force CD is also taken as tension. So this is the force table. Here I have indicated all the member forces and their magnitude and nature. Next we have to draw the force diagram. Using this force table, I am going to draw the force diagram. Again we have to draw the truss. It is consisting of 4 members and it is subjected to a load of 10 kilonewton. This is A, B, C and D. The first member force is compressive, so it is acting towards the joint, and this intensity is 5.75 kilonewton. BC is also a compressive force, so it is also acting towards the joint, and this magnitude is 11.5 kilonewton. Next, AC is tensile, so it is acting away from the joint. This is 11.5 kilonewton. CD is also a tensile, so acting away from the joint. This is also 11.5 kilonewton. So this diagram is called force diagram, and this is called force table. So the final results are interpreted like this, that is, we have to mention in the final answer in the form of force table and force diagram. This is very, very important.